Here in this video, we are solving a question that appeared in NEET 2025. The question is like this. To an AC power supply of 220 volts, 50 Hz, resistance of 20 ohms, capacitive reactance and inductive reactance are connected in series. The corresponding current in the circuit and what is the phase angle between the current and voltage. That's what we need to find out. So if you go a little deep, try to understand what is given for you. It's like a LCR circuit. What is an LCR circuit? There is an inductor, there is a capacitor, there is a resistance also. Resistance will have a resistance R. Capacitor will have an opposition to the flow of the current called capacitive reactance. Inductor will have an opposition to the flow of the current called inductive reactance, XL. And this is connected to an AC source who is having a certain voltage and certain frequency. This is called LCR circuit. When there is an LCR circuit, the effective resistance of the circuit, the total, is called impedance. So the impedance of the circuit is square root of XL minus XC whole square. Because inductor and capacitor are having a phase difference 180 degree, their difference has to be taken. And their resultant is perpendicular to the resistance of the circuit. So R square. So this is the impedance of the circuit. Now things are given for you like resistance R is given for you in the problem as 20 ohms. Capacitive reactance XC is given as 25 ohms. And inductive reactance is given in the problem as 45 ohms. As all these are available, I can easily calculate the impedance in the circuit. Yeah, it implies impedance equal to square root of XL 45 minus XC 25 whole square plus R square is 20 square. 45 minus 20 is also a 20. So this is root of 20 square plus 20 square. That is root 800, 40, 400 and 400. Which can be written like 2 into 400. So 400 out of the square root is 20. So impedance of the circuit is 20 root 2 ohms. That's what that's what we need to find out, right? Now let's find out what you want in the problem. Current in the circuit. Current in the circuit using like a Ohm's law, V equal to IR, I equal to V by R. But here not resistance because it's not a simple resistor circuit. An AC circuit, LCR circuit, so impedance has to be taken into account. Z, that what we have already calculated here. Now the voltage is given for you in the problem is already 220 volts. So current is 220 by 20 root 2. So these zeros can be cancelled to 11s. So this value is 11 by root 2 amperes. 11 by root 2 is 1.414. And if you calculate that value, you will get approximately that as some 7.79 amperes. So current is 8 amperes. So this option is ruled out. This option is ruled out because the currents are high. But both these currents are having same 7.8. Both these options are having. So to rule out which option is right, I need to go for the next part of the problem. That is finding the phase difference between them, right? So if I have to say how is that phase difference need to be calculated, I can draw a little diagram for an LCR circuit. On x-axis you can take resistance. On y-axis you can take the difference between XL and XC, and this is the graph between them. This is an angle, phase angle, which can be said like tan phi as XL difference XC by resistance. This is how we have to calculate the phase difference. Now let's calculate that. So what we can say? Tan phi is equal to XL difference XC is XL is 45, XC is 25. But resistance is 20. That is 20 by 20. That is equal to 1. Tan phi is 1. That means phi equal to 45 degree. Tan is 1 for 45 degree. So the phase difference is 45 degree, which is the right option. Here the phase difference is given as 30 degree. That's why that's a wrong option. That's how we have to solve this problem. So to solve this problem, we need to know one basic thing, that in a LCR circuit, the total opposition to the flow of the current is called impedance, which can be calculated basing on this formula. We can also calculate the current this way. We can also calculate the phase difference this way, right? These are the basics that you need to know to solve this problem, right? This can be taught in AC current of the second year syllabus. Thank you for watching.